No, you're good. Hi, Alina. Hi, Jerry. How are you guys doing today? We're going to give everybody just a couple more minutes to see if we get more people on, okay? No glasses today, Brian?
I don't have it right here. Well, now there it is.
Okay. There they are. I was going to say, you look so different without glasses on. Okay. Why don't we get started? So we only have 6 people today. No worries, though. We're recording so that everybody else can get it. So we'll start on homework. Does anybody have questions on the homework? Any of them that they wanted to go over? None? Okay. So I grabbed a couple or 3. These are all on page 171. I decided to grab these ones because there's a little mixture of everything we were doing, right? So for this first one, oh, here we go. Here's Ben. Okay. So for the first one, we can see it's just a trapezoid. So this one should be easy, right? It's 1/2, oops. 1/2 base 1 plus base 2 times the height, correct? So we can say that this base right here is 1 square unit. So B1 will be 1 plus, we can hit 1, 2, 3. So B2 will be 3. And then the height we can say is 1, 2, 3, and 4. 1 second. We got some more people coming in here. Got Max coming in. So I can say for this first one that the area of the trapezoid is 1/2 times 4 times 4. Ooh, got some more people coming in. Okay, awesome. Okay, so we can say 1 plus 3 is 4. And 4 times 1/2 is 2. 2 times 4 is equal to 8. So 8 square units. Oops, units squared, right? And that looks like it makes sense. There's 1, 2, 3, 4, and we can say 5, 6, 7, and 8, because those should all add up to be 1. This one here and this one, and this one and that one. Okay, does anybody want to try number 12? Go ahead, Brian. How did you do this one?
Okay, so what I did was 2 plus 1, 2, 3, 4, 5, 6. 2 plus 6.
2 plus 6. And that was your
2 plus 6 times 4 and times 1/2.
just like that?
Mm-hmm.
Okay. And so we got 8 times 1/2 is 4 times 4. You got 16.
Uh-huh.
It's squared. Yes, Jerry?
It should be oh wait, I'm looking at the wrong question. Sorry.
All good. No worries. Is that what you ended up getting then? Is 16 on this one too? Does that look right? I think that looks right. All right. So now what about for this weird looking one? Go ahead, Jerry. How would you want to try this one?
So I would add 3 and 5.
2 and 3. And then up here we have 5.
And then the height is 3.
3. So is there anything we might be missing for these two? Like, do we need, let's see, if I was saying, is this a regular trapezoid? Or do we need to create this? So then we have a trapezoid and a triangle. What do you think? Or can we leave it?
I feel like you could do it like either way.
Okay, so let's look at Brian's. Let's see if we can count 16 units, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost 11 for sure ones. So we can do, let's see, 1, 2, 3, 4. Yeah, so I think we can do it either way, like Jerry was saying. So here we can get 1/2 of 8, which is 4, and times 3 is 12, right?
Mhm.
Units squared. So let's check. We have 1, 2, 3, 4, 5, 6, 7, 8, about 9 units that are fully in there. And then this one will be complementary to this one. So that's about 10. And then we can say about 11, 12. So we don't have to break this down into numerous ones. We can just call this the trapezoid, and that will work because the 1/2 is already in here like it is a triangle. Does that make sense for everybody? All right, any more questions? Awesome. Let's move on. So we got a lot of stuff today. So we're gonna try to get through here. Kevin's in here now. All right, so the first thing we're gonna look at today is the coordinate plane. And that's the region formed by a horizontal number line and a vertical number line that meet at their 0 points, okay? So we're gonna look at polygons in the coordinate plane. So we were looking at polygons in the coordinate plane last time, right? With our square units. And so now we're actually gonna create these polygons. So we're gonna be given certain vertices, and then we have to draw it ourselves. So I'll do this first one, right? It's kind of harder to see. So A, we go 2, 4. So it always starts with your x-axis, which is right here. This is the x-axis, x. And this is your y-axis. And that will be your second number. So it always goes x, comma, y. Does that make sense for everybody? Okay. Oh, we got someone else coming in. Melissa's in. Perfect. All right. Okay. So when I'm doing this, I'll start 2, 4. So I go 1, 2, and then I go up 2, 4. And then I'll put my dot. And then B says 3, 9. So I do the same thing. 3, and then all the way up to 9. Oops. 9. And then I go 7 all the way right here, 7, 8. And then 8, 1. All right, so now we have our points. All we have to do is connect them, right? So we will have this weird little thing going here. Oops. These lines usually are straight. So that's a bad one. What it'll usually look like is straight lines. I was trying to make sure that like that. It'll look something like that. It's a little bad drawing. So that's what it will look like. Does that make sense for everybody? Any questions on that? Maggie, go ahead.
What page is it?
This is just lesson 9, 4.4. One second, let me check. 4.4 is page 174. It starts on.
Okay, thank you.
Yep. Yes, Alina?
Can I do one of the next ones?
Yes, of course. So I'll let everyone should get to do some of these almost. Let's see, Alina, we will give you 4. Okay.
Okay.
Let's see, Max, do you want to try number 1? Put Max right here.
Sure.
All right, you got it. We'll help you out if you need it. All right. Number 2, Brian, do you want to do number 2?
Okay.
All right. And Jerry, you want number 3? Cool. All right. Now, everybody else, if you didn't get one, still try them to make sure you get the same answers. Okay. All right. Let me know when you're ready. Okay, Max?
Okay.
Pretty sure I'm ready.
So, how would we show the shapes? Do we like draw them on paper and then like put it up to our cameras, or?
So you can just tell me what spots you want it at, and then
Okay.
I'll draw them for you, just to make sure you got your X and your Y right.
Okay.
Does that make sense? Unless you wanted to try to draw on here. I can let you guys try to draw.
Can you turn on the annotation button?
Of course. Here. Now everybody should be able to draw on yours. I think if you go up to the top and hit annotate, it will give you a little pen, and then you can mark your little spots. Here, I'll mark these so everybody doesn't draw on the same one. This will be number 1 right here for Max. Number 2 is right here. Number 3 right here for Jerry, and number 4 right here for Alina. So if you can't annotate, let me know. Oh, there you go. Jerry's got it, it looks like. Do you need some help, Max? Oh, there you go. All right. And then I'm just gonna, I forgot to do it on mine. So I'm gonna go through. So when Jerry did this first one, this one's A. This is dot A is 1, 3. 3, 6 was right here. That was dot B. It's kind of hard to see. There you go, Jerry. That was dot B. Then he had dot C. And then D. Perfect. Great job, Jerry. So Jerry's looks really good down here. It's kind of hard to draw, but that looks really good. And just make sure, I forgot to do it up top. If you mark your things, you can see A, B, C, and D. So that way you know which ones are which. Good job, Jerry. And looks like Max is getting it. Brian's getting it. Alina, can you annotate?
Yes, but can I ask a question?
Of course.
If you make the screen bigger, does it work? Or when it puts it smaller, is it in the different spot or something?
Let's see. So if you hit annotate, it should come up with like a little bar, right? And
Yeah, but
mouse select text. If you click draw, you can make it bigger. You do the second squiggly line down and it'll make it bigger. Go ahead, Jerry.
That's a highlighter.
Yeah, it's a highlighter, but it just makes it look a little bit bigger. So you could do like, if I had a dot, I could just go boop.
oops.
So it looks like that.
There is a line width on format.
Under format?
Let
Okay.
me just do the bullets.
So you can make it wider,
Did you
or
hear
you
that,
could
Alina?
make it not as wide.
So if you go under the format where it has the color, you can click line width and then it'll do the same. Got to get it on this one still. There. You just have to make like a little line. You can't make a dot.
Isn't that good?
You have to draw it a little bit. Yeah, perfect. That looks great.
And then
How are you doing over there, Max and Brian?
How should I do A?
A. So what is A? 0, 0. Where is 0, 0?
oops.
By the corner.
Exactly. So this is what we call the origin. So 0, 0 is right there. So you can just put a dot right there.
Okay.
Okay,
All
let
right.
me see where's the other dot.
So
Wait, let me first try to connect. No, actually, let me try to draw it.
Brian, yours looks really good. 4, 4, we have W. 7, 4, we have X, right? Y and Z. Just don't forget, we got to connect them. So you got a nice square. Awesome. Perfect. And then Max, yours looks really good. You got a nice little triangle here.
And then there is
A, B is 5, 7, and then 7, 4 is C. Good job,
that's fine.
Elena.
Let me draw that again. Is
Here,
that good?
Yours is perfect. I'm just going to mark these. This is P, and then we have 3, 5 is Q, 7, 3 is R, 6.5 is S, and then 2.5. Oh, you got a tough one.
Is
Perfect.
it there?
That's perfect. It doesn't have to be exact. And then can I connect them for you, or do you want to do it?
You can connect them.
All right. So then we just connect them, play a little connect the dots. Perfect. All right. So those all look really good. Does anybody have any questions on these ones? Any questions on how we got any of these answers? These all look great. So Max, you did a great job. You had a little triangle here, marked all of our spots, made our lines. All of these look really good. Great job, everybody. All right. Now these might stay, so I might have to delete them. We'll see. Yeah. All right. Sorry.
Should
Gotta
I delete it? Should I
Clear
try
all
to delete
drawings.
it?
I got it.
Okay.
Thank you, though. Okay, now we're going to move on to finding the perimeter. So can anybody remind me what the perimeter is? Go ahead, Jerry.
The outside length of a shape.
Perfect. So it's the outside length. What could go around that object? So I'm going to read this. The core concept, we're finding distances in the first quadrant. The first quadrant, so if we have this, right? If we had a real, oops, where am I at here? If we had like a real, where are we at? Okay, got to mark my pen. Okay, if we had a real 4 quadrants here, we'd have quadrant 1, 2, 3, and 4. Has anybody seen these before?
I seen them on these old-fashioned clocks, but I didn't really know what they meant. But I knew that they meant like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
Yeah.
12. But
So
I just couldn't remember them.
these are Roman numerals. That's not what we're so much interested in. We can write 1, 2, 3, and 4. Jerry, you've seen this before? Perfect. So this here, this is our one of our planes, correct? And this is quadrant 1. And it's quadrant 1 because all of these numbers are positive. And so how this works is we still have a number line. These go 1, 2, 3, 4, and 5, correct? And same with right here. It goes 1, 2, 3, 4, and 5. But if we're going this way, it would go negative 1, 2, 3, 4, 5. So we'd have negative 5. And same with this one. And so you'll notice this a lot as we go on, is different quadrants. Quadrant 1 has a positive x and a positive y. So 2 pluses. Quadrant 2 will have a negative x and a positive y. Does that make sense? Because you go negative x and then up. And so it's negative and then positive. Can anybody guess what quadrant 3 would be? Go ahead, Jerry.
Both of them would be negative.
Perfect. So we go negative and then we'd have to go down. So we go negative, negative. And Nicole, can you tell me what quadrant 4 would be?
It's a positive x and a negative y.
Perfect. So positive because we go up and then down, or to the right and then down. So all we're focusing on right now is our first quadrant. So everything will be positive. We'll make it super easy. Does that make sense for everybody? Because it's hard to have a negative perimeter. That's why. So I'm going to go ahead and start by writing the vertices of our rectangle. So we have 1, 6, 1, 6. And then we have 7, 6. Then we have 7, 2. and we have 1, 2. So this is going to be a nice rectangle. Okay, so now it says draw the quadrilateral right there and then find its perimeter. So like we said, the perimeter is what goes around, correct? So this one's kind of easy. I can do it two ways. I can do it a mathematical way with a formula, or I can just count, right? Because it's pretty easy. These are all square units. And so just like we did before, right? With the area, we can count. We went from 6 here. So we went 1, 2, 3, and 4. So we know our width is 4 units, right? And then we can go here and say 1, 2, 3, 4, 5, 6. And so our length is 6. So we have 2 of these and 2 of these. So we get 8 and 12, and we add them together. Our perimeter is 20 units. Right? Does that make sense for everybody? Any questions on that? Comments, concerns? Okay, so another way we can do this is I can look at my X and Y values from right here. Since they're given, I can look at 1, 6 and 1, 2, right? Because they have, oh, Melissa is back. Okay. All right. So since we have our X and Y values, I'm going to come down here, right? We have 1, 6 and 1, 2. I know that the X's are the same. So if I subtract these, right, I can subtract 1 and 1 and I get 0. That means there's no change in the x-axis, which makes sense because we look right here, we go 1, 2 and 1, 6. All we're changing is our y is right here. So 6 minus 2 is 4. And now we can come over here and see our width over here was 4. And so that's where that comes from. Then we can look at 1, 6 and 7, 6. So we can't subtract 1 from 7, but we can subtract 7 from 1, and we get 6.
I can't find the page.
In the book or
Okay.
on the lesson? Did you find it?
No.
I think it's 177 or
Yeah, this one should just be the next page or maybe 2 pages after what we just
I
did.
think it's 177.
Did you get that, Maggie?
Thanks,
Okay, so then we can see that our change in X is 6. And that's where this one comes from. Does that make sense for everybody? Do we see that? Any questions on that? So you can do it either way. Okay, here we go. Oops. Okay. Of course it's gonna do that now. Let's try this.
What was that? That was like a flipping book page thing.
Yeah, my stuff froze, and so I had to try to get it here. Where did we go? Microsoft. Okay, there. All right. So now we'll look at example 2. In a grid of the exhibits at a zoo, the vertices of the giraffe exhibit are 0, 90, 60, 90, 130, and 0, 30. The coordinates are measured in feet. What is the area of the giraffe exhibit? So go ahead, Alina. Did you want to try this one?
Yes.
Okay.
So then
I'm
we
just
first.
sorry, 1 second, Alina. Let me just say one thing. So
Okay.
if we look at this graph, it doesn't have 90, 60, 130s, right? It's going by ones. So what we're
Yes.
going to do is we're going to take these numbers and divide them by 10. Does that make sense?
Ah.
Right? So we'll go 0, 9, then we'll go 6, 9, and then we go 10, 3, and then 0, 3 for that one. Does that make sense? So that way it fits. Or on the opposite side, we can say instead of these being ones, we can say this is 10. So we can say between here is 10. Whichever way you want to do it, Alina, what are you thinking?
I want to like change the grid like to 10, 20, 30, 40.
Okay, so we got to just remember that these grids, X's, are by tens, and so are Y's, and Y's
Okay.
are by tens. So now we don't have to change these. We'll just remember. Okay?
Okay.
Would you like to, let's see, so 0, 90. 0,
0,
and then
90.
here, correct?
Yes.
Okay, so we go 0 and 9 or 0, 90. And then 6,
60,
9.
90.
So is that 6
No,
on the
6,
X?
9.
And then up right here. Does that look good?
Yeah.
Okay. And what's our next one?
100. So then that's 10 and 3.
Perfect. 10 and 3. And then
then 0, 30. So 0, 3.
perfect. And what shape do we have?
A trapezoid.
A trapezoid. Perfect. So we know that we can find the area of the trapezoid, right? Or yeah, of the trapezoid, because we know how to do that, right?
Yeah.
Do you want to walk us through it, Alina? How do we do
Yes.
that? So we have 1/2, right?
Yeah.
And then what's our first base?
Should I just count the squares, or
You can
should
do
I
it.
subtract it?
Whatever you think is easiest. With these ones, they're kind of big numbers, right? But here's an easy thing. We know that X starts at 0, don't we?
Yeah.
And so we can say for our first one, we went from 0 from 30, 0 to 100, right? So that's easy.
Yeah.
So we can put 100. So for the second one, what can we put, Alina? What do you think? So I'll give you a hint. If we look at these, we have a 90 for the Y and a 90 for the Y.
60.
Right. So that's this line right here. And so it goes from 0 to 60. And so we can say 60 for our second base. And so then what is our height? That will be our Y-axis.
Our height is Can I see it first?
See what? What do you need to see?
Like, I want to see the grid.
Yeah, can you see it right here? It's kind of hard to see.
Yeah.
So it goes from here's 30 and it goes up to 9. 30 to 90 or 3 to 9. And so
Is it 60?
perfect, yes. It's 60. So we could even look at right here. So if we looked, we have 90 for the Y and then 30 for the Y. So we can do 90 minus 30 and that'll give us 60. Perfect. Great job. And so we have 160 times 1/2 times 60, correct?
Yeah.
So let's see. This should be 80 times 60. Does that make sense?
Yeah.
Okay, and then 8 times 6 should be 48. And we have
And
two
then add
zeros.
the 2 zeros.
And units squared. Does that make sense? Jerry, do
Yeah.
you have a question?
It should be feet squared because it said in the problem.
Good call.
Yeah.
Good call.
Measured in feet.
So, good call, Jerry. There is units. The units are feet. Good job, Jerry. Good call. All right. Does anybody have questions on that? Does everybody feel good about that one? All right. Perfect. Oops. All right. We're carrying it again. All right. Hopefully it'll disappear. Okay, here's what we're going to do. So for the next exercise, verticals of a rectangle, find the perimeter and the area. So here's what we'll do. Give me 1 second to get rid of this stuff. And then we will come back. and do it. Okay, so here's what we'll do. I would like, let's see, Nicole, would you like to annotate the vertices onto this one?
Sure.
Okay. And then let's see, Maggie, can you find the perimeter of this one? So we'll do Nicole doing the vertices. Maggie will find the perimeter. Does that work, Maggie?
It's
And then,
so confusing to find pages.
well, you can try to use this one too, because that way you can actually solve it, and it'll be better than just looking at it. I promise.
Okay.
Ben, would you like to find the area?
Okay, sure.
All right, Ben will do the area, and then, oh, this is for the other one. Then we'll-
I don't have the sheet, so I can't really graph like the. Oh, do I annotate the screen?
So you don't have to annotate it. Nicole is going to put the vertices on here and annotate
Okay.
for us. And then Maggie will find the perimeter, and then you can find the area.
Okay.
All right? Yes, Alina?
So can you make another like coordinate plane problem and then like let everyone like find the shape, polygon on there?
Yeah. So let's see. So if you didn't get one, Nicole, do you know how to annotate on here? Sorry.
Um,
You do? Okay. Okay, perfect. Just making sure. Yes. So we'll do that, Alina. So here we go. We will do find the area of this one. I'm not going to give you the things. 1, 2, 3, 4, 5.
I have a question.
Yes. Go ahead.
So like the graph is kind of small and I can't really zoom in.
Okay,
Oh,
here.
could you just press it 2 times? It zooms in and then you can just.
I know, but it doesn't work for me. Mine's not a
Oh, you
touch
could just.
screen.
Let's see. Is that better?
Thank you.
Yeah, perfect. And then you should
that
1,
is-
2, 3, 4. Okay. Oops, let me
For me, if I press it 2 times, it's even larger.
Yeah, I can't do that because it'll blow it up too big. And then I don't have your guys' videos right here. So, okay, so we will go. These aren't by ones. We're going to go, these are by threes.
Oh,
Yep, so we're going to make it difficult. And this side's going to be by twos.
I've never seen one like that.
Nope, we're going to make it difficult just for you, Alina.
Really?
And then we're going to find, here's what we'll do. We'll go 9, 10 is the top. And then we'll go 6, 8.
Am I gonna find the area or the perimeter?
Both.
Wow.
Yep.
Okay.
All right. And then we'll go.
Can you draw the numbers down or something?
Yep. Hang on. Let's see here. So here's what we'll do. All right. That's your shape. Find the
Okay.
area and the perimeter.
Okay.
So we got right here, we have 9, 10. Here we have 6, 8. And here we have 12, 8. Here we
That
have
looks like a 13.
6, 6. Sorry. 12, 6. 15, 2. And over here we have 3, 2. So this is a 12. Oops. There. Does that look better?
Yeah.
All right, so if you didn't get on the first one, try to figure out the area and perimeter of this shape. All right, good job, Nicole. That looks great. Okay, so thank you for doing that, Nicole. That looks really good. Who do we have? Was it Brian doing the perimeter? Or Maggie? Were you doing the perimeter, Maggie? Okay. Did you get it figured out yet? Not yet? Okay. No worries. Ben, did you get the area figured out yet?
Well, I'm not sure what shape it is, so I'm gonna assume it's like a trapezoid.
Perfect.
So what you do for a trapezoid would you do base 1 plus base 2, which is 2 plus 3.
Perfect.
And then what I'll do is multiply it by the height, which is 7.
Yep.
And then instead of multiplying it by half, I like to divide it by 2 instead.
Perfect. That's perfectly fine too. And what did you end up getting here, Ben?
So 35 divided by 2 is 17.5.
Perfect. 17.5. Great job, Ben. That was perfect. I'm glad you noticed it was a trapezoid because we have a height, and then we have 2 different bases, a 3 and a 2. That was really good. All right, Maggie, did you find the perimeter?
I think so. I don't think I got it right though, because
No worries.
this is still a little confusing.
That's okay. So what did you end up getting for the perimeter of this one?
19.
19? Perfect. And I believe that's right because we have
plus
Yep.
17 plus 17. 7 plus 7 equals 14. Then 2 plus 5. 2 plus 3 equals 5. Then that's 19.
Exactly. So I like to do 7 times 2 is 14 and plus 5, 19. Great job, Maggie. All right. Did we figure out the area or the perimeter of our shape yet? Did anybody get it? Alina,
Not yet.
Jerry, Max, anybody? Nicole, did you get it?
Wait, so the area, the perimeter.
Of this one right here?
Wait, if you draw the squares, does
no.
it like match the squares or does it not?
So we have to look,
Wait.
right? Go ahead, Nicole. What's that?
So is it basically like a triangle, a square, and a trapezoid?
Exactly. So we have to write another one here.
Whoa.
So it's so you got 3 different parts. We have a trapezoid here that we have
I
to
think
figure.
I'm doing the trapezoid first.
And then we have a rectangle here. And then we have a triangle up here. So it's 3 different parts. So the triangle has a height of 2. And we can't really figure out the perimeter because we don't know what the length of this is.
Yeah, I'm just
So-
finding the area of the trapezoid for right now.
So here, we'll go through this kind of quick. So the triangle has a height of 2 and it has a base of 6 to 12. So it has a base of 6. So half of 6 is 3. 3 times 2 is 6. Triangle has an area.
I think the trapezoid is 16.
16, you think?
Yeah.
All right. So we would have our base 1 is 3 to 15, which is 12, plus 6 to 12, which is 6. So we'd have 18 times 1/2 is 9. And our height for this goes from 2 to 6. So that's 4. 9 times 4 is 32. So we were, 32.
No, I
Same.
meant the trapezoid.
This trapezoid right here?
Yeah.
Yep, it has an area of 32.
Okay.
Because we have to do our base 1, which is 6, and then our base 2 is 12. So that's 18. 18 divided by 2 is 9. 9 times our height, which is 4, is 32. Right? Yeah, Jerry, or 36, sorry. 36.
The area of the rectangle is 12.
Perfect. So we got 2 by 6. So we have 12. So now we'd have 6 plus 12 plus 36. So we'd have, let's see, 42 plus 12. The area is 54 units squared. Put U squared. The perimeter, we can't figure it out because we don't know yet how to get these sides. Does that make sense? So these have a very certain length that we would use another formula for, but we don't know that formula. So if we were doing the perimeter, we could only do the perimeter of this stuff. Actually, we couldn't because we don't know the length here either, because that's the same. So that was my bad. Just the area for that one's perfect. Okay. Does that make sense for everybody? Any questions or anything on any of those? Awesome. You all did really good. That was perfect. So let's annotate, clear it all. All right. So get out of here. Okay. Sorry. Having problems. Okay, here we go. So now we're looking at ratios. Who's done ratios before? Okay, perfect. Maggie, this is on 5.1. So we're on the next section, 5.1, ratios.
I stumbled on that page 18 times already.
Okay, perfect. So
Let's see which page.
our core concept is ratios. In words, a ratio is a comparison of two quantities. They can be part to part to whole, or whole to part comparisons. And so some examples are we can have 2 red crayons to 6 blue crayons. And that would be part to part because there's 2 different parts, a red and a blue. Then we can say 1 crayon for every 3 blue crayons. And so that is our part to whole because every 1 per 3 versus 2 to 6. And then we can have 3 crayons per 1 red crayon, which is the same as the other one, just opposite. In algebra, oops, let me get rid of that. Oops. Okay. The ratio of A to B can be written as A to B. Or another way we can write it is a fraction, is A to B. Does that make sense? We can say, so if we're writing these, we can say there's 2 red crayons to 6 blue crayons. Or if we simplify it, 1 red to 3 blue, right? That makes sense. Okay, so now we'll look at some examples. We're going to write the ratio of pennies to quarters. So I'll come over here. I got 1, 2, 3, 4, 5. I found 6 pennies to quarters. Let's see, there's 1, 2, 3, 4, 5, 6, 7 quarters is what I counted. So 6 to 7 ratio, or 6 to 7. Yes, Alina?
Could you let me do the last one or make one up for me?
Yes, we'll make sure that everyone tries some ratio problems. No
Okay.
worries. So now when we're looking at the ratio of quarters to dimes, we know there's 7 quarters. So I can say 7, 2, and let's see, we have 1, 2, and 3. So 7 to 3, or 7 to 3. Write the ratio of dimes to the total number. So now we know there's 3 dimes, and we have to have the total number of coins. So this means we have to include dimes, quarters, pennies, and nickels if we had any nickels. Yes, Jerry, do you have a question or do you have the answer?
Answer.
Okay, how many coins did you get?
I got 16.
16, perfect. So we have 7 quarters, 3 dimes, and 6 pennies. 7, 3, 10 plus 6, 16. So 3 to 16 ratio of dimes to total of coins. Does that make sense for everybody? Does anybody have any questions on that? Any comments, any concerns, or anything at all? All right, perfect. So, Alina, in the example above, can you write the ratio of dimes to pennies?
So dimes to pennies.
Yep.
Dimes are 1. Dimes are 3.
Okay. And what are pennies?
Pennies are 6.
6. Perfect. So we say 3 to 6. Can we say anything else besides 3 to 6? Like a simpler version?
3 to 6.
Right. So can that be simplified?
1 to 2.
Oh yeah, 1 to 2
There you
because
go.
it can be simplified.
Right. So 3 can go into 6 2 times. So we get 1/2. Does that make sense? Awesome.
Yeah.
Oh, perfect. Let me try this. Okay. There we go. There we go. All right. Now, the circle graph shows the favorite ice cream topping of several students. We're going to use ratio language to compare the number of students who favor peanuts to the total number of students. So here's what I want to do. We're going to do, Jerry will do peanuts to the total number of students. Let's see, Max. Oops. Max, can you do the fudge to the total number of students? Let's see, we'll go Brian. We're going to do sprinkles to the total number of students. Then we will do Nicole. You're going to do caramel to the total number of students. And then let's see, Alina, you are going to do fudge. Let's see, Alina, fudge to peanuts ratio. Kevin, we'll give you the sprinkles to fudge ratio. And then Melissa, we'll do the caramel. Oops. Caramel to peanuts ratio. And then Amber, you can do, let's see, opposite. We'll go peanuts to caramel. All right. Did I miss anybody? Did everybody get one? Maggie, I think I forgot you.
I didn't either. Oh, wait, did I?
I think you did.
Oh, Ben. Okay, Ben and Maggie. So Ben, you can do fudge to sprinkles. And then Maggie, you can do, we'll go, let's see, sprinkles 2 peanuts. Okay? Does that sound good for everybody? All right, and you can annotate it on there. That works perfectly fine. So it looks like Jerry got 5 to 19 for peanuts to the
Sorry,
total number.
my sound just got cut off for a second. Can you repeat what was mine?
Oh, Maggie, you got sprinkles to peanuts ratio.
Okay.
All right. So Jerry's, you're looking pretty good. 5 peanuts to a total of 19. That looks good, right? So we have 10, 5, and 9, 19. Good job, Jerry. Brian, is this yours right here? The 9 to 19? Or is that Jerry's?
No, mine is down below.
Brian, fudge to sprinkles. Where we got?
No, I am sprinkles to total.
Sprinkles to total. Oh,
Mine is fudge to total, I'm pretty sure.
Was I supposed to do caramel to total?
Mine is fudge to peanuts.
okay. So this one here is
It's
Max.
confusing.
So this is Max. Max, yours looks good. 9 to 19. That's perfect. Sorry. Ben, 9 to 4, fudge to sprinkles. That looks really good. 4 to 19. Is that one? Oh, here we go. This one's Brian. 4 to 19. Perfect. Oh, let's see. Nicole is 1 to 19. That looks good. Do we got everybody else on there? Did we get Alina? Where's yours at?
Here.
Fudge to peanuts. Oops. I see. 9 to 5. Sorry. It was right in the middle of my screen. Okay. We got Maggie right here. 4 to, what is that? A 9? Awesome.
Writing,
It's not as easy to draw here. I got you. No worries.
annotate.
Yep. Okay. So Kevin, did you get yours on here? Are you on there, Kevin?
This.
I did.
You did?
This.
Where's your, yes, you can erase it. Where's yours at here, Kevin? Sprinkles to fudge.
So the four cents without sprinkles, and there's 9 cents without fudge. So then I did 4 and 9.
Perfect. 4 to 9. Awesome. Amber, are you there? Are you there, Amber? Did you get peanuts to caramel? Melissa, did you get yours?
Yeah.
Did you write yours on here?
Yeah.
Where's yours at? What'd you get? Caramel to peanuts. Oh, right here, 1 to 5. Good job. Perfect. Awesome. And Ben, you got yours on here? Yep. I saw Ben, saw Brian. Nicole, I saw Nicole's. Maggie, awesome. Amber, are you there? Okay. So Amber is peanuts to caramel. And so it should be 5 to 1. Okay, perfect. Was that pretty fun? Did everyone enjoy that? That was awesome. It was
Yeah.
great watching everybody write on here. Okay, so now we'll move on. Let's see. So, yeah, Jerry, do you have a question? Oh, I can't hear you.
Your voice is cracking on my computer.
So is yours. It might be your computer.
Internet, maybe?
Do you want to try to get off and hop back on? We'll wait for you. Go ahead and hop off and hop back on. We'll see if it works. We'll clean everything up here in the annotation. Clear them all. Oh, someone didn't clear them all. Clear them all. Who's drawing on here? All right. We'll wait a second for Jerry. Does anybody have any other questions or anything? Our
The circle's
ratios,
following you again, I think.
I saw that. Are the ratios pretty good for everybody though? Pretty easy?
Yeah.
Good. All right, here's Jerry. We'll see if that worked. Nope, I don't see him. Where are you at, Jerry? There he is. Oops, at least we just have the circle falling. Better, Jerry? Awesome. Okay, perfect. So now we'll look at what if an example above the ratio is 2 to 3. Oh, whoops, we didn't even finish these questions, huh? Using a tape diagram. Oops, let me try to erase some of this stuff since we got another problem here. All right. So a tape diagram is a diagram that looks like a segment of tape and shows the relationship between two quantities. Make sure all this is gone. Okay, some of that stays. Okay. A segment of tape, and it shows the relationship between two quantities. Oops, 1 second. Oh, your speaker's not working? Can you try to talk, Jerry? No luck? Here, now try to unmute and see if it works. I can't hear you. If you want to try to hop off and hop back on, that's perfectly fine, okay? Can you hear me? Can everybody else hear me?
Yes.
Okay, so it must be
Yes.
Jerry. Jerry's having some troubles.
Jerry, maybe try to connect to a different network, I guess.
It might just be Zoom. Sometimes Zoom has troubles.
Yeah, Zoom uses most of your internet, so.
Yeah. Jerry, if you need to hop off and hop back on, feel free, okay? Or you can definitely just use the chat. I can leave the chat up for you.
Or annotation.
1 second. He can't hear. Okay, perfect. All right, so Jerry's going to try to do that again. Make sure get this thing down here and ready for him. Okay, so tape diagram that looks like a segment of tape, right? So we've seen tape. Oops, wow, that was bad. That was a really bad line. Whoa. Okay, so it looks like a tape, right? And so then it'll show, say we have a 3 to a 16 ratio. It's a segment of tape that looks 3 to 16 or any other numbers. So the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowance total is $40. How much is each allowance? So the total, so now we can draw in a total here. The total is $40. Oops, that looks bad. Hang on 1 second. Let me clean this up for everybody. There's too much stuff down here. Okay. All right. Let's see. Oh, guess it doesn't want to erase today. Okay. There, that's better. Okay. Let's try again. See if it'll write this time. I'm clicking all over here. So if we have a 5 to 3 ratio. There we go. Jerry's back. Perfect. All right, so if we have a 5 to 3 ratio and the total allowances are $40, we want to figure out how much each allowance is, right? So we have this cool thing where we go 5 times x plus 3y equals 40, correct? Or actually x, these are both x's because it's going to be the same amount of money. So we can say 8x is equal to 40. So each person gets $5 because we divide by 8 and divide by 8. We get $5 a piece. Does that make sense for everybody? Any questions on that? So here we saw some algebra, right? Yeah. Let's see. Jerry, can you hear now? Is everything better over there? 1 second. We'll try this. Okay. So now, what if in the example above, the ratio is 2 to 3? How much is each allowance? So 2 to 3 and $40. So we can say 2x plus 3x equals 40. And so 2x plus 3x is 5x equals 40. Divide by 5, x would be 8. Does that make sense for everybody? All right, let's see. So give me 1 second. There we go. Okay. Cool. All right, so anybody want to try the first example? Any takers? You separate 42 bulbs of garlic into 2 groups. Alina, you want to try it?
Yes.
Okay. Here we go.
So you draw this tape thing. So you'll plant 3 bulbs for every 4 bulbs.
So 3 to 4. Good now, Jerry? Awesome.
Plant. Separate.
So you separate 42 bulbs of garlic into 2 groups, one for planting and one for cooking, right?
Yeah.
You plant 3 bulbs for every 4 that you cook, correct?
Yeah.
Each bulb has 8 cloves. How many cloves will you plant?
Wait, is there 42 bulbs in all?
So there's 42 total. And there's a 3 to 4 ratio. And so if we have a 3 to 4 ratio, how many that we can find out how many we plant and how many we cook with, right?
Yeah.
Okay, so if we have a 3 to 4 ratio and we need a total of 42. Brian, did you have another solution or another way?
I also wanted to solve this too, but
You want, okay, why don't you help Alina out? What did you do here? Talk
also
to
what
us.
I did was 3 plus 4 equals 7, and 7 times 6 equals 42. So first we have to focus on the planting side. So 3 times 6 equals 18. So each bulb has about 8 cloves. So 18 times 8 equals 144.
Did you get that, Alina?
A little.
Okay, so Brian said there's 3 to 4 ratio, right? And just like we did up top, we can say 3x plus 4x is equal to 42, right? Because we're going to have the same number of bulbs,
Yeah.
or we're have the same number of bulbs. So we can say 7x is equal to 42. And so like Brian said, x equals 6, because 42 divided by 7 is 6. So now we can figure out exactly how many we're going to cook with and how many we're going to plant. So we can say 3 to 4 ratio, right? So we'll take our 3 times it by our 6, because that's what we'll plug in for x up here. And 3 times 6 is 18. So we have 18 bulbs that we are going to plant. Does that make sense?
Yes.
Okay, so now we have to figure out how many cloves there are. So we take 18 and multiply it by 8. And Brian, what did you say we got for that one? 106.
144.
Sorry, say it again.
144.
144 cloves planted. Does that make sense, Alina?
Yes.
Does that make sense for everybody else? Does anybody have any questions, comments, or concerns on this problem? Awesome. Okay. Thanks for walking us through it, Brian. That was perfect. So what if in the example above, you will plant 1 bulb for every 2? So now we do 1 to 2 ratio. Will you plant more or fewer cloves than originally planned? So now we do the same thing, right? 1x plus 2x equals 42. So we do 3x equals 42. And so we can say that x will equal 14. Does that make sense for everybody? And so 14 is just our x. So now we do 1, because that's the ratio, 1 to 2. 1 times 14, we get 14. Then times 8, correct? But I can look at this right now, and I can already tell you 14 times 8 is definitely less than 18 times 8. Does that make sense? We can look at it and say 18 is bigger than 14. So 14 times 8 is going to be smaller than 18 times 8. So we will plant fewer cloves. Does that make sense for everybody? Any questions from anybody about that problem or anything so far? All right, keep on going. Got a lot more. So 2 ratios that describe the same relationship are called equivalent ratios. We can find equivalent ratios by adding or subtracting quantities in equivalent ratios, or by multiplying or dividing each quantity in a ratio by the same number. We can find and organize equivalent ratios in a ratio table. Does that make sense? So we're going to complete these tables. 1 to 3, pens to pencils. And so this one will be pretty easy, right? We have a 1 to 3 ratio to start. So if our pens goes up from 1 to 2, that means we're multiplying by 2. We do the same to the bottom. 3 times 2, 6. Now, if we're going from 3 to 6 to 9, I know 3 to 9 is multiplied by 3. So I go 1 times 3 is 3. Does that make sense for everybody? Any questions on that one? All right, perfect. So now dogs to cats. Same thing, except this time we're doing the bottom first. 6 to 12, that's times 2, right? So 4 times 2 we get 8. And now we look 4 to 24. How do we get from 4 to 24? Can anybody tell me? Go ahead, Jerry.
You have to multiply by 6.
Exactly. So we multiply by 6 to get from 4 to 24. So we have to do it down here. 6 times 6, and we get 36. And that will be our equivalent ratio table. Does that make sense for everybody? All right. So let's see. Maggie, do you want to try number 1? And then we'll do, let's see. Nicole, would you like to try number 2?
Sure.
All right.
Sure.
Maggie, are you ready?
No.
No, not yet. Okay. I'll give you a minute and then we'll come back and I'll draw another table for everybody else so we can get some practice. Okay. Here's the table for everybody else. So we will do a ratio of, let's see, what do we want to do? What do you think, Max? What should we ratio?
I can't see what you wrote.
All you have to do is give me a word. What do you think? What should we do ratios to? Pens to pencils we have dogs to cats. We just need some other stuff. What do you think? Any 2 things? What are 2 things that you like, Max?
I don't really like Denny's.
You don't like, do you like candy? Here, what if we did candy?
Okay, I do like candy.
Yeah, I love candy. So we'll do candy to, let's see, what about broccoli? So we'll do 2 very different things. Because I like broccoli too, but they're very different. So we'll find the ratio from candy to broccoli. Right? Because we have to eat our broccoli for supper before we can have candy. So we'll say 1 piece of candy to 4 pieces of broccoli. And then
Okay,
down
done.
here, you're done? Okay, perfect. Let's see. So then I can say
Go to sleep.
2 and 12 and 16. All right. So here's for everybody else if you didn't get one of these 2. So try to work on this one. If you need any questions, feel free to ask. Maggie, are you ready?
Yeah.
All right. Walk us through it here, Maggie. What did you
Sorry,
get?
there's a bug flying around my room. I think since for earlier they're usually like add and multiply, I did for the first one for the plantains, I think.
Plantains?
Yeah, plantains. I subtracted it by 4 and I got 8, so I guess it's add 4 then.
Okay, perfect. So we have 8 here. That's great. That's perfectly good.
Then 3 plus 3 equals 6, so I add 6 and 3 equals 9.
Great. So you went the other way. Instead of multiplication and division, you can do subtraction and addition. Great job, Maggie. That's perfect. All right, Nicole, are you ready?
Yes.
All right.
So for the top, I got like multiply by 2, so I got 20.
So you got 20 right here. So you got to be careful because it's not going to be 20 here because then we would have 20 over 32. And that's not the same ratio as 5 to 4.
Oh, so I got down there, I got
I got 8.
So you got 8 right here. Perfect. And how did you
Yeah.
get 8?
I got 8
Which-
because 5 times 2 equals 10 and 4 times 2 equals 8.
Perfect. So now to figure out this one, instead of 5 times 2, we have to figure out 4 times something equals 32, right?
So I did 32 divided by 4, which is 8.
Perfect. So times 8. So then we take this 5 and we have to do the same thing times 8, because that will make it an equivalent ratio, is multiplying it by the same thing. And so what do you get here now?
I got 40.
Perfect. That's great, Nicole. 40. Awesome. Great job. Does that make sense for everybody? Awesome. Okay.
Yeah.
Alina, can you give me the first one here? 2 pieces of candy is how many pieces of broccoli?
8.
8. Perfect, because we multiply by 2. Jerry, can you tell me how many pieces of candy for 12 broccoli?
3.
3. Perfect. And Max, can you tell me how many pieces of candy we can have if we eat 16 pieces of broccoli?
4.
4. Perfect. Great job, guys. That was great. Any questions on any of those ones? Awesome. Okay. So now we'll make a ratio table. You're making sugar water for your hummingbird feeder. A website indicates to use 4 parts of water for every part of sugar. So 4 parts of water per sugar. So I'm going to say water and I'm going to say sugar. And it says we need 20 cups of water. So I know this is an easy one. 4 goes into 25 times. So times 5. So I do the same to the bottom, times 5, and I get 5 parts of sugar. Easy, right? So now this says, what if you use 24 cups of water? How much sugar do you need? So we can just keep going. So we'll write a 24. 4 to 24, that's times 6. And so we can do 6. Does that make sense for everybody? Easy one. Same with this one. You make a sweeter mixture of sugar water for your hummingbird feeder using 3 parts of water per 1 part of sugar. So we got water and we have sugar. It says you use 9 quarts of water. How much sugar do we need? Can anybody tell me? Jerry, how much? Perfect. Max, you got it. Go ahead, Jerry.
3.
3, because 3 times 3 is 9, so 1 times 3 is 3. Great job. Okay, let's see. Last few questions. So the nutrition, still using the ratio table, the nutrition facts label on a box of crackers shows there are 240 milligrams of sodium in every 36 crackers. So I'm going to say sodium over crackers, right? And so I can say there's 240 per 36 crackers. Now, if I eat 15 crackers, how much sodium is going to be in the crackers? How are we going to figure this out? Go ahead, Jerry.
So we have to divide 240 by 36.
Perfect. 240 divided by 36. And I can't remember. Okay, so it should be 6 2/3. So 240 divided by 36 is 6 2/3. So instead of using 6 2/3, we're going to change this to an improper fraction. Does that make sense? 6 times 3 is 18 plus 2. We'd have 20 over 3. So we can also say up here that there are 20 milligrams of sodium per 3 crackers. So now we have something that we can multiply to get 15. So just like Jerry said, now we'll do by 5 times 5, 20 times 5 is 100 milligrams of sodium in every 36 crackers. Oh, whoops, in every 15 crackers. Sorry. Does that make sense for everybody? Good job, Jerry. Thanks for walking us through it. All right, now we eat 21 crackers. How much sodium do we consume? I already know we did the 20 to 3. I know we have that. So to get from 3 to 21, how many times do we have to multiply it?
7.
Perfect. So 7 times. So 20 times 7 is 140. So we'd have 140 milligrams of sodium. And that makes sense because if we had 15 and it was 100, we'd have to have a little over 100. Perfect. So now it says, what if, an example above, you eat 24 crackers? How much sodium do you consume? I'm going to do this an even easier way. I know that adding 3 to 21 gives me 24. And so if it's a 20 to 3 ratio, if I add 3 on the bottom, all I do is add 20 on the top, and I should get 160. Does that make sense for everybody? Because we are just adding onto this one, this. And we can add the bottom. It's not a fraction, it's a ratio. So we can add the 3 to the bottom. All right, any questions on that? Perfect. So now it says you mix 3 pints of yellow paint for every 4 pints of blue paint to make green paint. You use 10 pints of blue paint. How much green paint do you make? So we have yellow, right? And we have blue. And so yellow, we have a 3 to 4 ratio. And we use 10 blue pints. How much green are we gonna make? Go ahead, Jerry.
I know that 4 times 2.5 equals 10. And so 3 times 2.5. So 3 times 2 is 6, plus 3 times 0.5 is 1.5. So 6 plus 1.5 is 7.5.
Perfect. So we have a 7.5 pints to 10 pints. So we need to figure out how to make the green paint. We add them together, and I got 17 1/2 pints of green paint. Does that make sense for everybody? Does that look good? Any questions on that one? All right. So now it says, what if in the example above you mix 2 pints of yellow to every 3 blue, and you use 5 pints of blue? Now how much? So 3 to 5. Now it's a little harder, right? Now it's not as easy as Jerry had it, where we could just multiply by 2.5, right? But I also know 2 plus 3 gives me 5 of green. So no matter what, I can add them. I can say, I can say 2 divided by 3 times something is equal to 5. Something over 5. So how do I get this, right? Well, I know if I do 5 divided by 3, my 3's will cancel out. So I can also take the top and multiply it by 5 over 3. And that will give me 10 over 3 to 5. Does that make sense for everybody? So that's kind of a tricky thing, but how it works is I have 2 over 3. And then when I do times 5 over 3, these 3's will cancel and I'd have 5 on the bottom. Does everybody see that? And so I know if I multiply this by 5 over 3, I have to multiply the top by 5 over 3. Nothing cancels out, but we look at this 2 is the same as 2 over 1. And so I can say 10 over 3 is equivalent to the 5. And now we can add them together, right? So 10 over 3 plus, I'm going to say 5 to 1 is equal to 15 to 3. Does that make sense? I'm just changing the 5 into a fraction so we have a common denominator. Because now we actually do have a fraction. This itself is a fraction. So I get 25 divided by 3. And so I believe that is 6 1/3 pints of green paint. Does that look good to everybody? That one was kind of a trickier one. It was a little bit more involved. So if anyone has any questions, feel free to ask, okay? Everyone feel good about that one? Thumbs up if you're good. If you think you kind of got it, you could do this. If you don't know at all, give me a thumbs down and I can answer any questions. What part was confusing for everybody? The 5/3 when I multiplied by 5/3? Yeah. So the only reason I did this was I knew this ratio. The only things I knew was a 2 to 3 ratio. And then I know from before, if we multiply the top and the bottom by something, the same thing, we will get our answer, but we knew the bottom was 5, right? We knew there was 5 pints of blue paint. So to get from 3 to 5, I know I have to take 5 and divide it by 3. And that's only because of the fraction and how the fraction works, right? This is 3 over 1, not 3 over 3, 3 over 1. So when these 3's simplify, I know I can get 5. So that's why I chose 5/3 as my fraction to multiply, is because I knew I would get my 5 pints of blue paint. It's a little confusing. It's a tricky one. Any more questions, comments, concerns? All right. Well, that's it for everybody. Monday, I will be posting a test for everybody to do on your own. You don't have to turn it in. It should be completed within an hour and a half. I'll post that today. And then I'll post the next lesson. So you guys will do that on your own. And there's also some more homework. Elena, do you have a question?
So for the test, can you use your lessons and stuff you did?
I would do the test without the lessons and stuff and make sure you can get it into your time frame. And then if you want to practice it, you can look at your stuff.
Okay.
Yeah, so it'll help you and it'll show you kind of where you're at and what stuff you need to work on at this point.
So an hour
Okay.
and 30 minutes, the test should be done?
What's that?
So an hour and 30 minutes, the test should be done.
Yep, in about an hour and a half. Yes, Jerry?
How long is the test?
It should take an hour and a half. I think it was something like 20 or 30 problems.
So is it going to be like a test, like on a link?
So I'll post it on there like I do with the lesson plans. And so then you guys can either print it off or make it a PDF and then just mark it on your paper or whatever you need to do. Oh. That's right. No books and no notes. The first time you do it, just sit down and try it with no books and no notes. And try to time yourself with an hour and a half. And then if you don't get it, that's okay. It's more so just practice. All right, does that make sense for
Wait.
everybody?
If you don't get it in 1 hour and a half, then do you just stop doing it, or do you finish it?
Yeah, so if you're doing your test and your time gets over and you still have more, go back and look at the stuff that you had to take more time on, because that's the stuff that you'll need more practice with. Does that make sense?
Yeah.
Okay. Maggie, one more question?
Like, what if we don't finish it within an hour and 30 minutes? Like, do we just stop, or do we just draw a line that's an hour and 30 minutes, and then
Yeah.
we can?
So the first time you do it, draw a line. And that way you kind of know where you're at. And then, like I said with Alina, go back and look at the problems that you had to take a little bit more time on and focus more on getting better at that stuff, because then it'll help you do that stuff faster. And so then if you
Okay.
wanted to try it again at the end of the week, still time yourself and then see if you can get past where you were. Does that
Okay.
make sense?
Mm-hmm.
Is
And
the test the only thing to do this week?
There is homework too, but I don't think the homework
Okay.
is as bad. And it's ratio stuff, so it should be pretty easy.
Okay.
Okay?
Are you
And
gonna post it or something, or just is it
Yep.
just on the back of the lesson?
So I'm going to post it. So the homework's on the lesson. It's at the very bottom. But I'm going to post the test. And so you guys will all see it. It'll be its own thing. And then Friday, I will post the answer key for everybody. Does that sound good?
Are you gonna to post the homework today?
So the homework's already posted. It's on the lesson
Okay.
plan.
Yeah.
Okay. Any more questions from anybody? Comments, concerns? All right. Well, everybody have a great rest of the weekend. I'll see you all next Saturday.
You do. You too. Bye.
Thanks for a great class, everybody.
Bye.
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 Goodbye.
Goodbye.
Bye.